Okay. So soil. There's a film called Dirt. Dirt's another word for soil, and it's an American word actually. Dirt, more than a British one, I think. Go play in the dirt. Anyway, so the opening sequence says that there's more life in one handful of dirt, earth, soil from our planet than any other planet they found to date. Okay, so an entire planet. There's more life in one handful of our earth, dirt, yeah, than any other place that they found. Okay. Now, that life may be visible, but most often it's microbial, so it's not visible to the naked eye. We need to put it under a microscope, and then everything becomes clear. So we're talking bacteria, fungi, protozoa. Okay, these things are smaller than we can see, but they should be there in healthy soil. Okay, and these guys are the key to fertility of our soils. If we don't have bacteria, fungi, protozoa in our soils, then basically we can say our soil is dead, and that being the case, plants will find it extremely difficult to grow in those kinds of soils. Okay? And our industrial scale farming, which uses chemicals and heavy tilling, kills a lot of that microbial life. So currently our soils in many parts of the world are very poor. They've lost a lot of their life, and they may have even just been lost entirely. Okay? Because what happens when you till the soil, you loosen it up and make it available for erosion. And we're going to divide soils into different layers. So we're going to say the top layer, and then we're going to say the subsoil. Okay, so the top layer is the place where most of our farming efforts are focused. And then the subsoils underneath are less important in some respects, but they're still part of the whole picture. Okay? Soil is made up of minerals such as silica, so sand, clay, you got silt as well, gravel, maybe rocks, like small pebbles, small rocks. Okay, and then there's an organic matter, it's called humus. So it's usually dead organic matter. Okay, so we've got different components for our soils. Let's talk about humus. So the humus component is the dead organic material. So this is material that was once living, that is now decomposed, and often gives the soil its black color. Okay, so the darker the soil, generally speaking, the more humus content is in the soil, and that's generally considered a good thing. Okay, lots of humus will usually mean quite fertile soil. Okay, we can also talk about texture. So if you have to get dynamite to loosen up your soil, then it's probably too hard, and if it just falls apart, you're probably on a beach. Okay, so you're looking for something a little bit in between. Okay, ideally you can put it in your hand and you can put it between your fingers and it forms small balls. Okay, like kind of small marbles. Okay, that's a kind of nice texture, and that's going to give you a clue that there is bacterial gels in the soil keeping it all together. Okay, and that will give you a clue that there's a healthy soil content. You can also smell the soil. You can taste the soil. Okay, in this same film, Dirt, there's, I'm going to say he's French, but I'm not sure. Might be Italian. Okay, he's in an orchard anyway, and he's tasting the soil. Okay, because what he says is he can taste the soil, and by knowing what the soil tastes like, he knows what the wine will taste like. Okay, because it has a direct consequence, a correlation. Okay, the soil will give you the food. Okay, it's all very much related. So good soil will give you good food.
So what should it taste?
Depends on, it may be an acidic taste or maybe an alkaline taste. So then we've got things like pH. Okay, if you remember from chemistry class at school, the pH table goes from 0 to 14, and 7 is neutral, less than 7 is acid, above 7 is alkaline or basic.
So it should not be basic or acid, it should be...
No, not necessarily, because one soil can be different to the other. Okay, so the conditions may be that the soil is alkaline, or the conditions may be that the soil is acid. Certain plants will prefer different conditions. An example would be in France, in the northern part of France, the soils are typically alkaline, and cabbages, the chou, comes from that area. Okay. Strawberries being a forest plant, like an acidic soil. So normally you wouldn't grow strawberries and cabbages in the same soil conditions. Okay, in the same acidic conditions, because one would prefer acid and one prefers alkaline. Okay, so if you would like to grow strawberries and cabbages in the same garden, then you're going to have to change the pH of your soil for one of your beds. So if you have alkaline soil and you want to make it acidic, you're going to add sulfur. Sulfur.
What is the name? Sulfur?
Sulfur. It's like the yellow mineral which has a slightly eggy smell.
Schwefel.
Schwefel.
Okay. And the opposite, if you have acidic soil and you would like to make it alkaline, you're going to add the mineral lime. Not as in lemon and lime, but it's a mineral called lime, or cal. Calc.
Kalk.
In Francais, calc.
In German as well.
Okay, calc.
Could we put bicarbonate dessous, no?
Yeah, you could do something like that. It's going to be, it's going to be alkaline, yeah.
Chalk?
Chalk?
Yeah,
Chalk's along that line, yeah.
Like they use it, like lime was used as well.
Calcaire.
Yeah.
Yeah, chalk bag.
Yeah. So you can manipulate the pH. Okay. The thing with soils is, however good or bad they are today, we can make them worse or better. We can improve soils, we can also destroy them. And generally speaking, we've been destroying soils. Okay? Either through erosion, literally being blown away or washed away into the sea, or destroyed through maybe mechanical tilling, ploughing, or chemical usage, or just using the same plant year on year on year. It just takes out the same minerals. Okay, so we've been destroying soils. But we can very much work with soils, and we can be sustainable. If we're giving back as much as we're taking, then we're sustainable. Okay, so that's what we need to think about with soils, is they're like a partner. Okay, and if we work well with that partner, we have a relationship which we can keep going forever. If we abuse our partner, then that partner will quit on us.
And we relive it when it's dead, the soil.
Yes, yeah, you can definitely, the soil that's dead, you can get it to come back to life again. You can revitalize it.
Okay.
It's definitely possible. It takes a little bit of time and effort, but it can definitely be done. And that's the good news.
Important thing, yeah.
That's the good news, because there's a lot of soils out there that are very damaged.
Yeah.
Okay, so we're going to talk today about some of the ways that we can repair soils. Okay, going back to pH. Okay, so we've talked about how to change the pH from acid to alkaline. If we also add any organic matter to the soil, so if we, let's say for example, we've got some grass cuttings and we put them on our garden bed and we allow them to decompose, then what's going to happen is, whether you have an acidic soil or an alkaline soil, the addition of organic matter will put the pH closer to 7. It will begin to neutralize whether it's acid or alkaline. Okay, by putting organic material, the soil will become closer and closer to a neutral pH. Okay, so putting something on top of the soil. This is going to be what we call mulching. Okay, so the word mulch, it comes from the forests. Trees that are deciduous lose their leaves, and those leaves then decompose and they're called leaf mulch. Okay, so mulch has then been taken as something that we're covering the soil. Why should we cover our soil? Okay, so we've often seen a field which has been ploughed by a tractor, maybe by horses in some countries, or 100 years ago in some of the European countries as well. What happens afterwards is the soil is then exposed. Okay, remember, the soil has lots of microbial activity, lots of microbial life, should have. Okay, so that sun is a beautiful energy source, but it's also very strong. Okay, it burns our skin, so imagine you're a little microbial organism. You know, what does the sun do to you? It fries you. Okay, so by leaving the soil exposed, the microbial organisms are killed, or they start to suffer. Okay, also the sun is very good at heating water, and if it heats water, it evaporates. Okay, so the water that's in the soil will be evaporated if it's exposed to the sun, meaning that it will dry up. Okay, also the effect of the wind. The wind comes along, it dries that top layer, and often if the wind is strong enough, it will blow away that top layer, leading to erosion. And also we have the rain. One raindrop comes from pretty high up, and when it lands, Gesundheit.
Thank you.
When it lands with a lot of power, and that same power can again lead to erosion, washing away the soil. Okay, so since we want to avoid all of those particular issues, what we're going to do is we're going to cover our soil and we're going to mulch it. So this could be with cut grass, it could be with leaves, it could be just the branches that we've been cutting, it could be the weeds that we've cut down and left to decompose around. Okay, there's all different kinds of organic mulches. Anything that was living is organic, and we can cover the soil. So now the sun is no longer hitting directly, there's a shadow element. So those small microorganisms are now protected, they've got a roof over their head. Okay, the sun again, its effect is being shadowed. Excuse me. So the water is staying in the soil. If you want to live in an arid climate where you've got more evaporation than rainfall, then water is so important. Okay, if you lose all that water through evaporation, you may be dead. As simple as that. So if you want to do farming in a desert, arid environment, you should have like 1/2 meter of mulch, keeping the water exactly where it should be, under the ground. Okay, so the plants can get to it. Okay, you're maintaining the humidity. Then we've got the wind. You know, again, if you've got a mulch covering, then the wind is now being dissipated. If you're in a really, really windy place, you may even need to peg down the mulch. You know, south of France, Mistral, you know, you may have to actually peg down a net to keep the mulch in place, or it's all blowing away. Okay, and again, rain, the energy is dissipated by hitting something, spreads out the energy, and so erosion is much reduced. As this is organic mulch, it's also going to decompose, and therefore it's going to improve the soil conditions by creating mulch. Creating humus, dead organic material. Okay, in some cases it will even help with weed suppression. So the plants that we don't want to grow, we're going to call them weeds, and by putting a cover on them, we're actually kind of excluding some of those weeds from being able to come up and compete with our target plants. Okay, you often see this in farms where they've used black plastic sheets. They put a big roll of black plastic, they cut holes in it, and then that stops the weeds coming up, and they just, you know, the particular plant they want to grow. So black plastic, of course, is then a pollutant, so we would try to avoid using black plastic, but perhaps you could use cardboard. Okay, and that will be carton. Yeah, carton. The packaging from televisions and apple boxes and whatever.
But then in cardboard you have a lot of glue and ink as well, so it may pollute the soil too.
I think it's offset.
Okay.
You know. And we're going to call this sheet mulching. Okay, here's a nice example of sheet mulching working well for you. So you're living in a house, it's got a garden, and there's a green lawn, you know, the grass lawn, and you've realized that you spend a couple hours a week cutting that grass, and it doesn't really give you anything. It's taking your energy and resources. So you make the right decision to convert that grass into a garden, a vegetable plot. So you go out there with a spade and you turn over the grass, and you think, okay, that's great, you plant some seeds, and you come back a week later and it's full of grass again. Okay, because grass will do that. It's a very, very, very competitor, very big competitor, very strong competitor. And so what is recommended is to go camping. Okay, if you cover the grass with a tent for a week, we know that the grass turns slightly yellow. Okay, imagine you put that tent down there for half a year, 6 months. You know, take it back, there's no grass, it's dead, the roots are dead. Okay,
6 months. That's long.
yeah,
It's competitive.
yeah. So, you know, and if it didn't require much effort, is the point. You just put something down, you take it back, and now the soil is in a good condition. There's no not too many grass seeds are going to pop up, so you can prepare your bed and plant your vegetables. Okay, so soils, we've also got different conditions within the soil. So as if sometimes you've got a lot of clay, sometimes you've got a lot of sand. Okay, and what you're looking for ideally is something called loam, but you may have, you know, extremes of either side. If you have a lot of clay in the soil, then this could be a good thing. If you would like to stop water, okay, if you want to make a pond and you don't want to use a black plastic liner, then you can line that pond with clay and it will seal, okay, and so the water will not escape. And the same if you, for making a dam to create a big body of water, then you can seal it with clay. If the soil has at least 50% clay content, okay? So how do we know if it's got 50% clay content? Real simple soil test is the jam jar test. Okay, the marmalade glass bottles. Okay, empty the marmalade or eat it, whatever. And probably eat it, it's a good idea. And then you take some water. Shake Arnie, he's falling asleep. Can't fall asleep, and you can't fall asleep.
I'm back again. A bit away.
That's the problem with sitting in the hammock, you see.
You said something about the clay with the water, and then
There you go. You're just there. You're just there. I know you fell asleep for like 30 seconds. But. Okay, so we need 50% clay content in our soil, and I said, how do you know how much clay content's in your soil? You use a jam jar. Okay, so you've got an empty jam jar, you put some water in it, you put some of your soil, you shake it all up so it's all floating around, nicely agitated, and then you let it settle for, could be 24 hours, and it will settle into different layers. So at the bottom will be the heavy stuff, the silts, and then the clay, and then the organic matter on the top. Okay, and if you've got 50% or more clay content, then that will stop water passing. Okay, the water will stay on top because the particles in clay are smaller than water.
How much water are you supposed to put in the jam jar, sorry?
Well, not quite to the top. So you got room for it to slosh around.
Just put water, you just
Yeah.
put soil in it.
Yeah, let's say 3/4 full.
3/4 water.
3/4 full with the
with
the soil in it.
Ah,
Yeah. You need it to be liquid enough that it all,
ja,
you know.
ja. Wie viel Wasser?
Ja, dann ist er halb voll und dann hast du ein
Yeah, it
bisschen
could be
mehr.
like half full and then a quarter, right? As you just said in
Yeah.
German. I understood perfectly. Okay. So that's a simple soil test. A more advanced soil test will require you to take a sample and send it to an agronomist. And they will do a bunch of chemical tests and they'll send you a bit of paper back saying you've got these elements and these percentages, and you may need a 3-year university degree to understand what it means. But you know, it was $100 well spent, I'm sure. Here's another thing to think about with samples though. You know, if you're on a property, even a small property, there can be significant differences between different sample sites. Okay, so you may need to take more than one sample. Okay. So back to farming. So our farmers, they use artificial fertilizers to feed plants. Okay. And if you buy an artificial fertilizer, it's from the petrochemical industry, and it has usually 3 letters on the side. It's NKP. Okay, so that's N is nitrogen, which is azote in French, quite a different word. And then K is potassium and P is phosphorus. Okay, so these 3 elements are, we're going to call them macro nutrients. Okay, they're needed in large quantities by plants. Carbon is also needed in large quantities, but that's available in the air through carbon dioxide. Okay, so we don't need to worry about that. But the other 3, we need to provide them to our plants. Okay, we don't want to use an artificial fertilizer, so we need to think about how can we supply those 3 elements naturally. Okay,
Again, it's azote.
azote, nitrogen,
potassium.
potassium and phosphorus. Okay, so we're going to start with nitrogen. What natural sources of nitrogen do we know about?
trees.
Trees. Okay, in what sense?
In what sense? You said something about that, I thought.
I did say something about that. What did I say about that, Ani?
They're also producing it, right?
Okay, so it's true that animals and plants contain nitrogen. So if you decompose any of those things, you will provide nitrogen to the soil. Okay, but there's certain plants which have a higher content of nitrogen availability. Do we know what they are? Anybody?
Beans.
Beans. Okay, so beans and peas, they are leguminous plants. Okay, for those of you not aware with the term leguminous, basically if you were to take up a bean plant from the soil and look at its roots, you would see little white nodules. Okay, those white nodules are a colony of bacteria, and those bacteria are fixing atmospheric nitrogen. The largest component of our air, apart from space, is nitrogen. Okay, but plants normally can't get it, but these nitrogen fixing bacteria can. Okay, so the bacteria get the nitrogen, they give it to the plant, and the plant gives them starch, sugars. Okay, so it's a symbiotic relationship. It's also important to note that, yeah, this plant is using a lot of that nitrogen, but there's also an excess. So other plants around a nitrogen fixing plant will be able to obtain some of that nitrogen. So there's a benefit to being a neighbor of a leguminous plant. Okay, so if you've got your leguminous plant here, you're the neighbor, you're getting a free lunch. Okay, you're getting that excess nitrogen. Also, and this is quite common, you get like a rotation system. So one year you would sow a nitrogen fixing plant, and the next year you would sow a plant that needs a lot of nitrogen. Okay, because there's always going to be a residual amount of nitrogen left in the soil from the nitrogen fixing plant. Like alfalfa, what's alfalfa? And then followed by corn. Yeah. So anyway, the idea is that you can have a nitrogen fix and then follow it with a plant that needs a lot of nitrogen. It's quite a common rotation system, and it's also very useful to put in a fallow year, a year where you do nothing. Okay. The important thing about soil, if we do nothing, it will repair itself. The plants will repair it. Okay, different plants are able to extract minerals. They're able to put things back in place. They're able to neutralize toxins. Okay, you can actually detoxify soils with plants. Okay, they'll take out the toxins. They'll put them into long carbon chains and basically make them inert. Okay, so plants are very good at bioremediation as well as repairing the soil. If it's compacted, you get a plant with a deep tap root and it kind of decompacts, like thistles, dandelions. Okay, these are plants that have a big strong root and they decompact the soil. After burning, okay, the soil is left low in phosphorus after the burn, and so plants like the brackens and ferns, okay, they're some of the oldest plants on the planet. They were still around in the dinosaur age. Okay, and these guys, they were able to extract that from the ground, and if you cut them and allow them to decompose, the next year there'll be less of them. If you cut them and burn them, next year there'll be more of them. Okay, by burning we do release a certain amount of nutrients. Most of the nitrogen is lost. Sometimes there's a increase of phosphorus, but generally burning is a bad thing. Okay, it releases a lot of pollution to the air and destroys a lot of the microbial activity on the top and causes a lot of destruction to the other animal networks. Some animals obviously perish in fires and insects, etc. So it will create monocultures. Grasses like it being burnt. They got a good root network and they just grow back again, but a lot of the plants around them will be dead.
How's it with ash? Ash is normally good as soil, right?
Huh?
Ash. So the adding ash to soil, yeah? Yeah, for sure. Because the ash will contain elements which will help. Okay? So we've said leguminous plants, okay, for nitrogen, but we've got a couple more nitrogen ones. Okay? So also we have urine and animal feces. Okay, manures. They're both high sources of nitrogen, including ourselves. Okay, literally guys, you can take your pee-pee and you can dilute it with water and you can put it on your plants. Okay, and your plants will be happy. Okay,
Your
if it's
pee?
your pee, your urine. Okay, because it contains a lot of nitrogen. It contains a lot of nitrogen. So if you pee directly onto a small plant, you may even oversupply the nitrogen. You can burn it. Okay, so you should dilute your urine. If it's a tree, it doesn't matter so much. If you need a pee, find a tree. Okay, that's a common expression. But again, too many people peeing on a tree, like in a Glastonbury style festival, then they're going to kill the trees as well, because they're oversupplying a particular nutrient.
Does it make the soil acidic as well? Or is it not enough? to do that?
No, I don't think it'd be too much of a problem. Okay. Okay. The poo element again. So fresh poo is very high in nitrogen. So I'm really talking about herbivore poo. You know, animals that eat vegetables. That's going to be your
Or vegan people.
vegan people. Yeah, for sure. Okay. And so these are going to be, to start with, quite high in nitrogen content, so it's better to let them dry and then use, if you're putting it onto your plants, do it when it's dry. It gets kind of messy when it's wet as well. Okay, and the other source of nitrogen is lightning strike. That fixes atmospheric nitrogen into the soil. So if you happen to know where lightning struck, and I do in this case because a tree up there got hit by lightning, then around that tree would be high in nitrogen.
Can we somehow use nature therefore, like attract the
lightning?
Yeah,
lightning?
what you can do when it's raining next time, you stand out with an umbrella.
Yeah, but
Yeah, and we can all stand up with our cameras.
it could be possible as well, but maybe a bit less harmful for me.
Yeah, lightning's one of those ones that's more difficult to predict, etc. Easier to manipulate and use leguminous plants, pee and caca.
Okay.
Okay, so
That's the way.
and safer. So let's think about phosphorus. Okay, phosphorus. There's high phosphorus content in bird manures. Okay, so if you've got free-range chickens, every time they do a little doo-doo, they're depositing phosphorus around the farm for you, around your backyard or on your kitchen table, wherever. Okay, if you don't have chickens but you have birds, which hopefully you do in a natural environment, then you could encourage them. Imagine you put a post in the middle of your vegetable patch, and every time that bird comes and perches on the post, stretches its wings, does a little poo, so around the post to be high in phosphorus. And you've also doubled up, now you've got a sentry guard, a security guard. It's guarding your vegetables, looking for, you know, insects that it could eat for lunch. Okay, so you've got a double function there.
And they're beautiful also.
And they're beautiful, okay? Also, in the bottom of places where fish are kept in water, then after a while the sediment builds up, and that sediment is basically fish poo, and fish poo is also very high in phosphorus. So if you have a fish farm operation, generally what happens is they reduce the water level to then harvest the fish once a year, and then they would clean the pond, and that silt can then be put around the garden. High in phosphorus, you get a bumper vegetable crop. Okay, and what was our third element?
Potassium.
Potassium. Okay, so potassium is potash. Okay, and potash, you can get high quantities of potash from worm farms. Okay, from the worm casts. Okay, so you can either collect worm casts from the ground, or if you've got a worm farm, then you can use them to produce potash for you. Next thing we're going to talk about are composts.
Is there any other way to get potassium into the soil rather than digging up worm farms?
Yeah, put anything green on your soil. Anything like green cut grass, green leaves, it all contains a lot of potassium. Okay, so composts. So basically how we can create a compost. There's tons and tons of different ways to make a compost, guys, right? And some of them require more effort than others. The one we're going to cover today does require a little bit of effort, but it's very quick. It's called the 18-day compost. Okay? So in 18 days we can take our raw ingredients and then create compost, which we can then use directly as a soil amendment to improve our soil conditions, okay, for plants. So here on this farm, what we take is a third cow poo, okay, a third cut green grass, and a third dry brown leaves. Okay, so really you need some sort of animal manure, then you need a green element and you need a brown element. So the green is nitrogen, the brown is carbon. Okay, we're always talking about carbon and nitrogen when we're talking about composts. Okay, they should be evenly balanced. So some people like to do lasagna composts, where they're doing layers. They do green, brown, green, brown, green, brown. Okay, so that's like a lasagna compost. But we're not doing that. We're just talking about the 18-day compost. So we take a third in volume cow poo, a third in volume cut green grass, a third in volume dry brown leaves. Okay, we mix them all together and we add in water. Okay, if it's dry it will not work. If it's too wet it will not work. It should be that if you were brave enough to pick it up and squeeze it, you get about 1 drop of water out of it. Okay, so not too wet, not too dry. Okay, so you've mixed this all together and you put your water in. If you've got some old compost, also put some old compost in there, because this is a biological activity, so there'll be the biological agents like the microbial agents in the old compost, which if you put them in the new one it will speed up their presence. If you don't have one, don't worry, all these things are all around us at all times, so they will get there in the air. Okay, so we're going to leave that pile, we're going to cover it with tarpaulin so the rain doesn't go up and the water doesn't evaporate, and we're going to leave it for 4 days. After 4 days we're going to come back and we're going to turn it. Okay, your compost heap should be no less than 1 meter in cubic volume. Okay, that's important because if it's less than 1 cubic meter it won't heat up enough. If it's much bigger, it's a pain in the butt to turn it, because turning it basically means moving it from there to there. So if you're doing it with a spade, it's a lot of work if it's really big. If you've got a tractor, go for it. Do it 20 meters if you want. Okay, but if you're doing it by hand, it's advisable to do it not much more than 1 meter, but no less than 1 meter in cubic volume. As I said, this is a hot process. So what you're going to find is that during the first week if you start to touch your compost, it will start to feel warm, if not hot. Okay, and that hotness is because it's an aerobic process. Every time you turn it, you are introducing air, oxygen into the process. If you don't turn it, then that pile will use up the oxygen and it will turn into an anaerobic process. And that's a different kind of microorganisms. Okay, so we're going to do an aerobic one. It produces heat, it's hot. This hot is going to kill pathogens and it's going to kill weed seeds. Okay? So the first 4 days you left it, then the 4th day you turned it. And then every other day, so day 6, 8, 10, 12, 14, 16 and 18, we're also going to turn it.
Every 4 days.
Every 2 days.
Every 2, sorry.
So basically on day 20, 2 days after turning it, on day 18, you're good to go. You've now got compost which is rich in lots of sexy nutrients for the plants. So that's how to make one type of compost. Okay, it's a lot of work. Okay, so I would only do compost for selected activities, like, you know, when I'm making potting mix. Okay, so potting mix is when you get your little bag and you get your seed. You know, what you put in the bag, you put in something called potting mix. Okay, because it's special soil which you've made or you've bought, which is good for getting things started. Okay, it's high in rich in nutrients and it's easy to move around, it doesn't stick together. Okay, so how do you make that? You take a third compost, a third sand, and a third the best soil you can find, and you mix them together. And when you've mixed them together, you've got potting mix, and you put that potting mix in your bags, and then you can put your seeds or your cuttings or your saplings into those bags, and they will thrive, hopefully, because they've got the right nutrients. You know, a little seed only has a very limited amount of energy. If it spends that energy trying to break through hard soil, it's using its energy rather than growing. So that's why we put, you know, sand in there. It helps keep it nice and loose. It helps it well drain as well. Great. So we know how to do a compost, but we live in an apartment in the city. We've got no space to do these kind of things. There's no cows around here. You know, what am I going to do?
Lombricoposter.
Move to the countryside.
Move to the countryside. Well, there you go, there's an option.
Worms.
Worms. Okay, perfect. We've got the answer.
Horrible.
So we could very easily have a little worm farm. Okay, not everybody's cup of tea, as Naomi says. You know, the idea of worms, ooh, scary. But in reality, these guys can be your best friend. Okay, they eat their weight every single day. Okay, so you can give them your organic waste from the kitchen. Okay, and they will consume it. They don't eat everything. They don't like, you know, lemon and things like that. But a lot of the things they will consume, and they will produce two things. They will produce liquid gold and they will produce solid gold. Basically pee and poo, but, you know, we'll call it liquid and solid gold because our plants will consider it that way. So if you've got your liquid gold, you know, you get a little tap at the bottom and you can drain it off, you can dilute it with water and you can spray it onto your soil, and it will basically nourish the soil and the plants, and they will thank you for it by producing fantastic crops. And the worm farm will fill up with a solid. Once it's filled up, you literally just put a second layer on with a hole between the two layers. You put your food on top and the worms will migrate up from the bottom layer to the top layer, and then you can empty your bottom layer and use it for making potting mix, like that best soil you can find example. Or just as a normal soil amendment. Okay. Not all plants need or want super fertile soil. Carrots, for example, prefer almost sandy soil. Okay, so before assuming that all plants need the same as the other, do some research. Final question we've got today is the till or not to till question. Okay,
Still.
what is tilling? Okay, when we plow, we turn the soil. Okay, so now we are aware that there should be plenty of life in our soil, including earthworms, moles. Earthworms are fantastic. They're going up and down. They're little miners. They go down, mine down there, bring it back to the surface, spew it out, returning nutrients to the top all the time. So they're recyclers. Their pathways allow oxygen in there, air, the water can percolate. The more earthworms you've got, the better. Okay? They're a really good friend of a gardener and farmer. So we've got this case where we should have lots of life, okay? And a farmer comes along with his plough and turns the soil because he deems that he's trying to decompact the soil and also put air in there, okay? But what's really happening is this, okay? Imagine Paris or New York or Berlin on a Friday night, okay? You're out there, you live there, and the biggest motherfucking earthquake ever hits your city. It's a 10 on the Richter scale, you know? Turns everything upside down. Boom. Monday morning, your phone's somehow still working, you know? The boss phone's like, you coming to work? You what? Yeah, I'm coming to work. I don't know where my house is, I don't know where the office is, all the roads are destroyed, and you want me to come to work? But it's exactly the same we do with the soil. We turn it upside down. We have all these nice little networks. We're organized. The microorganisms are kind of like, I know where my house is, I know where my work is, I know what I'm doing. And yet, it's like, oh, let's go back to work, guys. Come on. You know, if you do that on a regular basis, year on year on year on year, you know, you're just making it worse. You're just, literally, you know, your biodiversity is depleting significantly. If you do it once, okay, you're preparing a bed. Okay, sometimes it's rock hard, you need to, okay, you do it once, fine, it can recover. But don't do it every year. Okay, that's just like torture. And even if it's rock hard, you know, there's other ploughing systems which can, you know, they can literally just lift the soil like a little chisel plough. It just puts it out, boom. There's like a 5 on the Richter scale rather than a 10. Boom. Just allow some air in there. You know, you can do ripping as well. So instead of turning, it just cuts slices in the soil. That's really good for getting water in there. So there's alternatives which are much less destructive. So the till or no-till is no-till.
There's something we call grelinette in French.
Yeah,
something with
right.
like
And then
4 or 5 fingers or until
Yeah.
7 fingers, and you just like you make space in the soil and you don't turn anything, and then you go back and do another
It's
one.
just
You
making
put
holes.
air. So,
and
Yeah,
Okay,
it's super,
that's kind of
super
ripping,
good.
I guess. Yeah.
Yeah,
Yeah. So yeah, there's
Grelinette.
yeoman plows. Yeah. Yeah, I think when you plow, right, they're saying like decompaction, but that heavy machinery actually it's compressing underneath. So it leaves a layer of compressed soil underneath. So in fact it's not very, very good at all.
So why do mainstream farms use tilling?
Because they believe that it's useful for them. Because it does, to a certain degree, decompacts that layer and puts in oxygen, which on a short-term basis gives you an advantage. But on the long-term view, it's depleting all your microbial activity. And so you're creating a long-term problem. Okay, it's a short-term fix, long-term pain. Short-term gain, long-term pain.
Het is ongelooflijk.